The water and waste system installed in the aircraft supplies the spigots and coffee makers in the galleys, lavatory sinks, and toilets with water from a potable, that is, drinkable, water tank. The used water, so-called gray water, can be drained overboard. The waste from the toilets will be collected in a waste tank and emptied on ground by a service truck. The water system is pressurized by air. The potable water system supplies pressurized potable water for food service in the galleys and for washing in the lavatories. The potable water system is pressurized by bleed air and an optional air compressor. The potable water is stored in a central holding tank, whose usable capacity is 110 liters. The water lines are installed inside the pressurized, temperature-controlled environment of the fuselage. A filtration system is provided in the galleys to improve water taste and quality. The gray water system enables draining of the serviced water from galleys and lavatory wash basins. Draining is performed by drain masts located in the forward and aft sections of the fuselage. A Water and Waste System Controller, WWSC, operates and monitors the system components and evaluates failure status. The controller is designed to include all the necessary software and hardware components to support all possible standard and optional configurations. The vacuum waste system provides waste collection and storage from the toilet assemblies located in the lavatories. It uses either a vacuum generator at low altitudes or differential pressure between the cabin and ambient at high altitudes to transport the waste from the toilets to an aft-mounted waste holding tank, whose usable capacity is 95 liters, 25 gallons. The titanium waste lines are installed inside the pressurized, temperature-controlled environment of the fuselage and are routed from the toilets to the waste holding tank. During a toilet flush cycle, the vacuum waste system uses a small amount of pressurized water from the potable water system to rinse the toilet bowl and aid in the evacuation of waste. During ground servicing, the waste tank is drained through a drain valve, drain line, and service panel into a service truck. A rinse line routed from the service panel to a rotating rinse nozzle within the waste tank is used to supply rinsing fluid to the tank. The potable water system supplies pressurized water to the water spigots and coffee makers in the galleys and to the water heaters and faucets of the lavatories. Water is also supplied to the lavatories for flushing of the vacuum toilets. The potable water is stored in a potable water tank located in the aft center fuselage 3 section of the aircraft under the floor behind the rear bulkhead of the aft cargo compartment. Bleed air pressure is used as the primary pressure source of the system. The bleed pressurization line is routed from the main AC bleed air duct up to the water tank inlet distribution air manifold. The tap-off point is placed in such a way as to provide bleed air either from the engines or from the APU. The bleed air is filtered and regulated to the system operating pressure of 30 to 40 psig. As an optional feature, an air compressor is used to pressurize the water system in case the aircraft is on ground with the engines or APU not running, or if the bleed air pressure is below the optimal range during flight. The following optional items are available: in-flight drainage of the entire contents of the potable water tank and supply hoses, lavatory water heater, potable water filter for the lavatory faucets. Potable water is added through the single service panel. The service panel is located on the aft left-hand side of the fuselage and contains the fill drain nipple, fill drain switch, service panel door switch, and indication panel. The usable capacity of the potable water storage tank is 110 liters. The tank has an air cushion volume of 10 liters that provides proper dampening of tank pressure as a function of variation of consumption at several different end-of-use points and variations of bleed air pressure. Potable water is distributed from a single tap below the potable water tank via the distribution lines. Reinforced supply hoses are installed in the pressurized zone under the floor cabin, except in the wing area, where the water line is routed above floor behind the dado panels. The water lines to each consumer are equipped with a manual shutoff valve for system isolation and maintenance. Water is supplied to the sink by a wall-mounted faucet located above the sink basin. The potable water in the lavatories is also used on the rinse valve in the vacuum toilet assemblies for flushing. The supply lines to the wall-mounted spigot and the coffee maker rail assembly in the galleys contain a water filter. A water and waste system controller, WWSC, is mounted in the aft avionics compartment. The WWSC monitors and controls the components of the water and waste systems, interacts with flight attendant's panel and the cockpit drain panel, and communicates with the centralized maintenance computer, CMC. Communication with CMC is through MAU1 via the ARINC 429 bus. WWSC also receives flight and attitude information from the aircraft through the MAU3 via the ARINC 429 bus. The WWSC controls and performs the following functions: system fill process, system drain process, water tank level monitoring, in-flight draining of gray water, in-flight draining of the potable water, valve opening and closing, drain masts heating, compressor operation, built-in test of water system components, indication of water system status to cockpit, flight attendant panel, and service panel. Communication with the MAU for fault messages displayed in the CMC. For ground surfacing, the WWSC incorporates a hot bus mode feature that allows system filling and draining without electrical power from either the AC generator or GPU. The service panel door switch enables hot bus power to the water and waste system controller for 6 minutes when the service panel door is open. If power from the DC ground service bus and DC bus 1 is not available or fails to supply power, the water and waste system controller automatically switches to hot bus power to allow system filling and drainage. The potable water storage tank is located behind the aft cargo compartment bulkhead, below the cabin floor crossbeams in the center fuselage 3. The tank is mounted horizontally with 2 band clamps. The tank is supported by a structural cradle that is attached to the aircraft structure. A flange on top of the tank incorporates ports and fittings for the overflow line, air pressurization, air pressure switch, and the level sensor. The electrical connector for the level sensor is integrated into the flange. At the bottom of the tank, a flange connection provides an interface to the fill, drain, and distribution lines. The usable tank capacity is 110 liters. The tank has an air cushion volume of 10 liters that provides proper dampening of tank pressure variations of the bleed air pressure. An overflow tube set at 101% of tank level is provided to limit tank volume in case of malfunctioning of the control loop and as a protection against overfilling. The water tank capacity limit can be configured to 35, 70, or 90 liters by changing the water and waste system controller pin programming. The system controller, in conjunction with the level sensor, limits the usable quantity to the predefined volume. water supply is provided by pressurization of the air cushion above the water level. The nominal system pressure inside the tank is 36 to 41 psig, 2,482 to 2,826 hectopascal. The water level sensor measures the volumetric quantity of water stored in the water tank. The level sensor is integrated into the top flange housing of the tank. The sensor is a cylindrical tube capacitive type. The unit acts as an electronic sensing probe and provides continuous measurement of the water level. Input voltage is 28 volt DC provided by the WWSC. The output signal increases if water level increases and vice versa. The signal processing electronics are integrated into the sensor assembly. The output signals are transmitted to the WWSC and then to the flight attendant panel. The aft flight attendant panel provides water quantity indication and system fault indication to the cabin attendants. Water quantity is provided at 0, 25, 50, 75, and 100% tank volume levels. Potable water filters are installed in the galleys to remove unpleasant tastes and odors, organic pollutants, dirt, amoebic and other cysts, algae and invisible particles as small as 2 to 5 micrometers in diameter. The filter reduces chlorine levels to fractional parts per million to improve taste and prevent recontamination of the water from internal bacteria growth. The filter element is an ultrafine straining material, is disposable, and must be replaced at periodic intervals. Note, the filter is not designed to convert non-potable water into potable water. The potable water service panel is located on the aft left-hand side of the fuselage. The panel contains the fill-drain nipple, fill-drain switch, service panel door switch, and indication panel. The door switch of the water service panel is used to connect 28 volt DC from the hot battery bus to the water and waste service controller during ground servicing when no aircraft power or ground power is available. The service panel indicator shows the tank volume status and the position of the system valves during system servicing. The indicator panel contains 2 green LEDs marked full and drain. Input power is 28 volt DC and is supplied by the WWSC, which also controls the indicator lights. A cuff heater is installed on the fill-drain nipple to prevent clogging of the line from residual water freezing. The heater is an electrothermal device made of silicone elastomer, which operates on 115 volt AC single phase from the AC ground service bus. A self-regulating thermostat within the heater maintains the temperature above 38 degrees Celsius, 100 Fahrenheit. The fill-drain switch enables ground service operation of the system. The fill-drain switch has 3 positions for selection: fill, normal, and drain. The switch is turned to the normal position if the service panel door is closed. A device on the door structure is installed to prevent closing the service panel door in case the switch is not in the normal position. The fill-drain valve allows filling, draining, overflow, and ventilation of the water system on ground. The valve is a 4-way, 2-position ball type that is operated by an electric motor. The valve is controlled from the water and waste system controller. The normal position of the valve in flight is closed. The valve includes a mechanical indicator of the valve position that may be used to manually open or close the valve in case of a fault condition. Nominal operating voltage is 28 volt DC, supplied to the valve through the WWSC from the DC ground service bus or the DC bus 1. The actuator is designed not to exceed a temperature of 100 degrees Celsius and is monitored by a thermal protector. The drain valve is designed to withstand freezing conditions with water in the inlet port. In case of a water system leak in the supply line in either the galley or lavatory, the water system may be isolated by means of the manual shutoff valve. The valve is clearly placarded and accessible by the flight attendant without the use of tools. The shutoff valve is a ball-type valve that is normally in the open position. The aft drain valve serves to drain the potable water tank in flight. The valve is included as a part of the in-flight drain option, and in flight is normally in the closed position. The valve is a two-way ball type that is operated by a water and waste system controller controlled electric motor. The valve includes a mechanical indicator of the valve position that may be used to manually open or close the valve in case of a fault condition. 28-volt DC power is supplied to the valve through the WWSC from the DC ground service bus or DC bus 1. The valve contains a printed circuit board with motor control circuitry and a thermal overheat protector set to 100 degrees Celsius. The thermal protector removes power from the motor in case of an overcurrent condition and automatically resets to the closed position when the temperature falls below the tripping point. The forward drain valve serves to drain the forward potable water system line on ground or in flight. The valve is operated by electrical signals from the WWSC. The normal position of the valve in flight is closed. The valve is identical to the aft drain valve. Warm water at the forward and aft lavatory wash basins is provided by lavatory water heaters. They are located in the lavatory cabinet underneath the sink and installed in the supply line to the faucet. The lavatory water heaters are cylindrical tanks of about 1.5-liter capacity. Power is supplied from the AC ground service bus 1. The water tank is designed to operate with a cushion of air at the top under normal inlet water pressure. This prevents damage to the tank if freezing should occur. A relief valve prevents excessive pressure buildup within the tank. The pressure relief setting is 140 psi, 9.53 bar. Note, the water heater does not provide a continuous supply of hot water. Maximum water temperature recovery time is 15 minutes, with 15 to 18 degrees Celsius, 60 to 65 Fahrenheit initial water temperature. Gray water auto drain valves are installed below the lavatories and galley sinks. The valve drains the wastewater and prevents the loss of air through the empty and open sink. The design allows continuous water drainage under small fluid heads and prevents backflow. The valves open at a maximum water head of 178 millimeters, 7 inches. When no differential pressure is applied, such as on the ground, the valve drains and no residual water remains in the valve. It is acceptable that the valve remains open on ground. In flight, the valve remains in a closed position until there is a head of wastewater at the inlet. The valve then opens automatically in order to drain the wastewater. The drain may be opened manually by the cabin attendant in case of a clog. The ring handle at the top of the valve is pulled up to open the valve seat and clear the line. The gray water holding unit has a gray water drain valve and an intermediate tank. The unit is connected with pressure and vacuum resistance hoses to the lavatory and galley sumps, and to the drain mast. It has the capacity to collect 3.8 liters, 1 gallon, of gray water from the galley and lavatory sinks while the aircraft is on the ground to prevent spillage of fluids out of the drain masts onto the tarmac. The valve is operated by an electrical signal from the WWSC. In flight, the valve opens to drain the stored gray water overboard via the drain masts, or on ground when commanded from the fill drain switch. The normal position of the valve is open in flight. The valve is similar to the forward and aft drain valves except the end fittings. The drain masts are used to drain potable and gray water overboard. The drain tubes and the bottom foot of the drain mast are made from a copper alloy. 115-volt AC single-phase 400 Hz power is supplied from the AC ground service bus 1 through the SPDA1 to the drain masts. The drain masts contain a heater with overheat protection, a safety thermostat, and a thermistor temperature sensor for external temperature regulation. The WWSC temperature control circuit will enable or disable the SPDA to provide power to the drain mast heater to maintain a temperature of 71 degrees Celsius, 160 Fahrenheit, at the sensor inside the copper base. A safety thermostat is embedded in the drain mast to inhibit draining through the forward drain valve in case of the drain mast heater failure. The safety thermostat is set to open when the drain mast temperature falls below 5 degrees Celsius, 41 Fahrenheit. This opens the power supply circuit to the forward drain valve and prevents draining of potable water. Filling is started by opening the service panel door on ground, attaching a fill hose, and turning the fill drain switch to the fill position. The fill drain valve is commanded to the open position, enabling water to be filled into the water tank via the fill drain nipple at the service panel. The opened valve also enables tank ventilation and overflow via the aft drain mast. If the water tank becomes full, the fill drain valve closes automatically, and the full indicator is illuminated at the service panel. If the fill drain switch is returned to normal, the full indicator is extinguished. If power from the normal power sources, DC ground service bus, and DC bus 1 is not available, the WWSC automatically switches to hot bus power mode to allow system filling and drainage. During servicing, a minimum of electrical power for valve and the tank level sensor operation is consumed by the WWSC. When the fill drain switch is returned to the normal position, all valves automatically close. A 10-second timeout period is incorporated to shut down the WWSC and avoid battery depletion. The service panel door switch disconnects the WWSC from the hot bus every time the service panel door is closed. On ground, draining is started by opening the service panel door and turning the fill drain switch to the drain position. The forward and aft drain valves and the fill drain valve open automatically, enabling water in the tank and tubing to drain via the forward and aft drain masts and the fill drain nipple. The fill drain switch also enables the forward drain valve to open during cold weather conditions by overriding the safety thermostat inside the forward drain mast. At water-consuming locations, shutoff valves must be opened. The faucets and coffee makers self-vent in order to clear the lines and avoid vacuum lock. At the service panel, the drain indicator light illuminates, indicating that all valves including the gray water drain valves are open. If the fill drain switch is returned to normal, all valves close and the drain indication is extinguished. If no power is available from the DC ground service bus or the DC bus 1, the drain servicing procedure is available by means of hot battery bus power. Gray water is automatically drained from the forward lavatory and galley through the auto drain valves and directed to the forward drain mast of the aircraft. Gray water from the aft lavatory and galley is drained through auto drain valves and directed to the aft drain mast. The auto drain valves allow for drainage of liquids on the ground and in flight, and prevent loss of cabin air. The valves are installed inside the respective galley or lavatory. The drain masts are dual drain port type. One port is used for potable water drainage and the other to drain gray water. The two optional intermediate gray water tanks, which are installed in the forward and aft sections of the underfloor area of the aircraft, collect gray water on ground from the forward and aft galleys and lavatories. Electrically actuated motorized valves are installed under the intermediate holding tanks to allow for draining of the tank in flight or on the ground. The valves are controlled and actuated by the water and waste system controller. 2 minutes after landing gear retraction, the gray water holding tank drain valves open automatically, allowing overboard drainage of the water accumulated on ground. Both valves remain open during the rest of the flight. In-flight drainage of the potable water is commanded by pressing the water dump push-button indicator located in the cockpit console. The aft drain valve opens automatically, and the cockpit water drain indicator is illuminated by the water and waste system controller. The water in the potable water tank will be drained via the aft drain mast. The compressor is deactivated by the WWSC, and the forward drain valve is opened automatically 3 minutes after water quantity inside the water tank is measured as 0%. This completes the in-flight drain process. The in-flight drainage is inhibited via WWSC software in case the landing gear is down or the temperature sensor in the forward drain mast has detected low temperature. The forward and aft drain valves are then commanded to close. A capacitive type level sensor measures the water level within the potable water tank. The potable water tank level sensor is continuously monitored by the water and waste system controller. The quantity is indicated at the flight attendant panel in 0, 25, 50, 75, and 100% figures. During servicing, a green full indication is provided at the service panel when the tank reaches the full level for the selected configuration. The water tank full level depends on the customer configuration and is limited to a maximum of 110 liters. The actual tank is always the same, but the different levels are selected by WWSC pin programming via the aircraft interface harness. There are 4 different water tank quantity configurations depending on the aircraft configuration: 35, 70, 90, or 110 liters. The Waste and Water System Controller is able to monitor failures of components and send failure messages to the flight attendant panel and CMC. Failure messages are addressed to the flight attendant panel only if they affect flight attendant duties or passenger comfort. Detailed failure information can always be reviewed by use of the CMC. Wastes from the lavatories is carried by a vacuum system to a remote waste holding tank and is later drained into a servicing cart. At low altitudes, a vacuum generator, and at high altitudes, differential pressure between the cabin and ambient is used to transport the waste from the toilets through the flush valve to the aft-mounted waste holding tank. Titanium waste lines carry the waste to the holding tank. They are installed inside the pressurized and temperature-controlled area of the fuselage. The vacuum waste system makes use of pressurized water from the potable water system to rinse the toilet bowl and aid in the evacuation of waste. The waste tank can be drained through a drain valve, drain line, and service panel into a service truck. After the tank has been drained, it will be cleaned with water supplied through the service panel to a rotating rinse nozzle in the waste tank. The system is operated and monitored from the WWSC. 1 to 3 toilets can be installed in the aircraft aft left, aft right, forward left, and forward right. Conditions for normal use of the vacuum waste system are: electrical power is available. Waste tank is not full. service panel door is closed and pressurized water is available at the toilet rinse valve. When the toilet flush switch inside the lavatory is momentarily pushed, the toilet flush control unit, FCU, mounted on the toilet times and sequences the operation of the vacuum toilet. If altitude is below 18,000 feet, the vacuum generator is actuated through the Water and Waste System Controller, WWSC, to evacuate the waste holding tank. At higher altitudes, the differential pressure between the cabin and ambient is sufficient to transport the waste. Prior to opening the toilet flush valve, water is introduced into the toilet bowl through the rinse valve to rinse the bowl and aid in waste evacuation. When the rinse valve closes, the toilet flush valve is opened and the waste is evacuated to the holding tank. 10 seconds after the flush switch actuation at low altitudes, the vacuum generator is disabled and the toilet is again ready for flushing. Note, if the waste tank is full, the WWSC disables the toilets to prevent further flushing and overfilling of the waste tank. Waste tank draining is performed by ground service personnel after a flight. Draining is started by opening the waste system service panel door on the right-hand rear side of the aircraft. There is a switch on the service panel that inhibits system operation when the door is open to eliminate the potential of waste spilling on ground service personnel or unintended operation of the vacuum generator that could cause suction of rinse fluid or waste liquid. On the service panel there is a secondary drain connection, a rinse nipple, a service panel switch, and a drain valve cable handle that connects to the primary ball drain valve located at the outlet of the waste holding tank. The Water and Waste System Controller, WWSC, monitors and controls the components of both the water and waste systems. The controller interacts with the aircraft flight attendant panels, CMC, the MAU, and LICC, AICC, SPDA1. The WWSC controls and performs the following functions for the vacuum waste system. Waste system component fault monitoring via internal and external built-in test. Waste tank level monitoring at 75 and 100%. Initiation of vacuum generator operation at low altitudes. Indication of waste system status to flight attendant panel. Communication with the MAU for fault messages to be displayed in the CMC. The WWSC is normally powered from the DC ground service bus. If this one fails, power is supplied from DC bus 1. If the water system service panel is open and no other power supply is available, the WWSC will automatically switch to the hot bus. Note, this supply is limited to 6 minutes and not available for the waste system. The vacuum toilet assembly is a self-contained freestanding unit. It consists of a solenoid rinse water valve and strainer, composite flush valve, the flush control unit, FCU, bowl and spray ring, anti-siphon valve, and supporting frame. The support structure for the toilet is primarily welded stainless steel. The toilet assembly can have either right or left discharge configurations. 28-volt DC is supplied to the toilet assembly by SPDA1 or SPDA2. The 28-volt DC toilet rinse valve allows water to flow to the anti-siphon valve for delivery to the toilet flush ring when energized. Even with no water in the system, the unit will still operate correctly. The rinse valve seals at essentially 0 psig by using an internal float device, thereby ensuring that the unit will not leak. The anti-siphon valve has a floating sealed poppet that is pushed up against a stop when water is introduced. After water flow stops, the poppet drops back down, closing off the return path of the water. The toilet incorporates a 28-volt DC motorized rotating disc-type flush valve, which ensures that no odors are allowed to migrate into the cabin during shutdown of the aircraft. The flush control unit sequences the operation of the vacuum toilet and reports rinse valve and flush valve switches and internal faults through the WWSC to the CMC. The FCU allows approximately 210 milliliters of water through the anti-siphon valve to the flush ring. It also controls the flush valve by causing it to open into the flush cycle and remain open for 4 seconds. The FCU also signals the WWSC that a flush is occurring to allow the WWSC to turn on the vacuum generator for 10 seconds if needed. The waste holding tank is mounted between the aft left lavatory and the pressure bulkhead above the floor level. The usable capacity is 25 gallons, 95 liters. Brackets welded to the side of the waste tank wall are used to mount the tank to the aircraft with adjustable tie rods. The thin-walled stainless steel tank is completely sealed on the inside and will resist the impact loads caused by heavy solid objects that may be flushed into the waste system. The tank can withstand a pressure of 50 psig, or a vacuum of minus 12.6 psig. The tank has inlet and outlet ports, a rinse inlet, 2 level sensor ports, and a water separator port. The composite flow diverter within the tank is positioned perpendicular to the incoming air waste flow from the lavatories. Due to this geometry, the velocity of the solid and liquid matter slows down significantly more than the surrounding airstream. The airflow continues to move towards the inner portion of the flow diverter. The geometry also ensures that the incoming waste does not foul the level sensors, which could lead to false full messages. The water separator mounts at the top of the waste collection tank with a single V-band clamp and connects to the aircraft vent tubing. The separator is composed of 2 separate sub-assemblies, the water separator positioned within the waste holding tank and the filter housing positioned above the tank. The filter housing incorporates an internal stainless steel mesh that must be removed and cleaned frequently to ensure optimum system functioning. A clogged separator will cause slow transport of waste in the system and may lead to blockages in the waste lines. The water separator will remove entrained moisture from the airstream that carries the waste into the waste tank. Because of the centrifugal action, the moisture is thrown to the outside walls of the water separator chambers, from where it then drains back into the tank when the flush is complete. This ensures that no contamination is passed through the vacuum generator or exhausted from the aircraft through the vacuum exhaust plumbing. The water separator has an orifice at the outlet to limit airflow. This assures that no contamination will be exhausted from the aircraft. Limiting the airflow also prevents depressurization of the cabin in case the toilet flush valve failed open. A rotating rinse nozzle is installed in the waste tank to achieve optimum cleaning of the interior of the tank, especially the level sensors. The spinning rinse nozzle uses the principle of a water bearing. Water pressure acts as a lubricant between the rotating nozzle and the stainless steel shaft, allowing free rotation of the nozzle. It is designed to clean the tank inner walls, liquid level sensors, flow diverter, and outside housing of the in-tank water separator. It is also used to supply pre-charge fluid to the waste tank. two capacitive-type level sensors are used on the waste tank to detect liquid on the sensing surface. They are located so that fluid in the tank is detected when it reaches 75% and its full or 100% capacity. The sensors are electrically connected to the WWSC to transmit a 75% or full signal. The 75% indication is used as a convenience to allow the crew to know that servicing will be required soon. The sensors also have a test input that is used by the WWSC to detect faults. Sensor failures will be indicated on the CMC. The vacuum waste system uses an electrical brushless motor-driven vacuum generator. The unit is attached to 3 vibration mounts that are in turn mounted to the rigid aircraft mount close to the waste holding tank. The 2-stage centrifugal flow vacuum generator is powered by 3-phase 115 200-volt AC at 400 Hz from the AC ground service bus. The vacuum generator only runs for 10 seconds during each low-altitude flush cycle. The waste drain ball valve is installed underneath the waste holding tank. The valve can be mechanically opened by a lever, which is connected to the service panel handle by a cable. 2 seals, one on the inlet and one on the outlet, ensure that no waste products are allowed to leak from the waste holding tank. The valve is mounted in the waste line at such an angle as to ensure that waste will not remain in the valve after draining. Pushing the handle on the service panel back in will close the valve again. The vacuum waste system service panel is installed on the rear right-hand side of the fuselage. The following parts are installed on the service panel: the service panel drain valve, rinse fill nipple, the service panel switch, and the waste drain ball valve handle. The aft aircraft flight attendant panel provides waste quantity indication and system fault indication. The water and waste system controller monitors the waste tank level sensors and sends an output signal to the flight attendant panel to indicate the correct quantity. At 75%, the service tank light illuminates, and at 100%, the tank full light illuminates. Forward or aft lavatory fault indications are provided on the FAP by the WWSC when a signal from the respective toilet due to a motor fault or switch fault, or if the FCU blower signal to the vacuum generator stays on for more than 5 minutes. The waste fault light will come on if the vacuum generator is in an overheat condition, the 75% and 100% level sensors have failed, or if the WWSC is faulty. If both level sensors have failed, the system will be deactivated and considered full. Further fault information can always be found on the CMC. The Toilet Flush Control Unit, FCU, mounted on the toilet, times and sequences the operation of the vacuum toilet in the following order after the toilet flush switch has been pressed. If altitude is below 18,000 feet, the vacuum generator is actuated through the WWSC and the motor starting relay to evacuate the waste holding tank. Approximately 210 milliliters of water is introduced into the toilet bowl through the rinse valve to rinse the bowl and aid in waste evacuation. As the rinse valve closes, the toilet flush valve is opened for 4 seconds, and the waste is evacuated to the holding tank. 10 seconds after the flush switch is pressed, the vacuum generator is disabled and the toilet is again ready for flushing. At altitudes above 18,000 feet, the differential pressure between the cabin and ambient is sufficient to transport the waste and the vacuum generator will not be powered. The airflow bypasses the vacuum generator through a check valve to the overboard vent on the right-hand side of the aircraft. If the waste tank is full, the 100% level sensor in the waste tank notifies the WWSC, which then disables the toilets to prevent further flushing and overfilling of the waste tank. The following procedure is used to drain the waste tank. Open the drain valve cap and connect the drain hose. Open the rinse nipple cap and connect the rinse hose. Push the drain valve lever to open drain inner flapper, secondary drain. Pull the drain cable handle to open the ball valve, primary, to drain the waste tank. After the waste tank is drained, start the rinse fluid supply and rinse the tank for a minimum of 2 minutes. Push the drain cable handle to close the ball valve. Pre-charge the tank with 6 to 8 liters of rinse fluid. Turn off the rinse fluid supply. Disconnect drain and rinse hoses. Close the drain valve cap and rinse nipple cap. Clean the surface of the panel to remove spillages. Close and latch the service panel door. Mechanical stop devices on the service panel door will not permit the door to be closed if either of the valves is open or if the drain cable is not fully seated. One stop device enables operation of the system by closing the service panel door switch contact. The potable water system is pressurized by engine or APU bleed air and an optional compressor. The bleed air is tapped off from the cross-bleed duct in center fuselage 2. The air is routed aft through the fuselage and connects to the air manifold in center fuselage 3. Bleed air is introduced via an air manifold into the water tank to provide regulated pressurized potable water. The air manifold includes a shuttle valve, regulator, air filter, check valve, and pressure relief valve. The air manifold regulates the incoming air pressure to the working pressure level, cleans the air, prevents water from entering the air system, and prevents overpressure in the water system. The optional air compressor is provided to improve the pressure stability of the system when bleed air pressure is insufficient. Air compressor cycling is controlled by the water and waste system controller based on the signal from a pressure switch that is mounted to the water tank. The compressor is switched on if the bleed air pressure is too low. The compressor supply line is connected to the second port of the shuttle valve. The air manifold receives pressurized engine bleed air, APU bleed air, or pressurized air from a compressor. The air manifold is installed in the air line to regulate the compressed air supply to the potable water system. The air manifold contains a factory-adjusted relief valve and pressure regulator, an air filter, a non-return valve, and a shuttle valve. All functions are combined in one housing, so that only 2 inlet ports and 1 outlet port have to be connected to the aircraft. One inlet is connected to the compressor line, and the other is connected to the bleed air system. The outlet fitting is connected to the potable water tank. The pressure switch is located on top of the water tank in a threaded mounting boss on the tank cap. The switch detects insufficient pressure inside the tank and signals the WWSC to turn the air compressor on. The pressure switch has a membrane to detect the pressure difference between cabin and tank. Upon switch contact closure, a ground signal is sent to the waste and water system controller. The switch is set to turn the compressor on at a tank pressure of 35 psig, 2413 hectopascal, and to switch off at a pressure of 38 psig, 2620 hectopascal. The air compressor is de-energized during ground servicing to avoid unnecessary cycling. The WWSC will disable the compressor under the following conditions. The service panel switch is in fill or drain position, and weight on wheels condition is true, and the aircraft speed is not greater than 2 knots. If the pressure switch on the tank does not indicate full system pressure after 30 minutes with water in the tank, a pressure system fault will be indicated on the CMC. Compressor failure, pressure switch failure, or a leak can lead to this indication. In this case, the compressor will not be disabled in flight and will cycle while the aircraft is on ground.